Okay, ladies and gentlemen, welcome to the video notes for area of composite figures. This is for geometry class and represents the next lesson in our area and perimeter unit. So here we have the equations from our previous lesson for the area of a triangle, 1/2 base times height, the area of a parallelogram, which would include rectangles, squares, rhombus, and parallelogram. That is base times height. Area of a trapezoid, which is 1/2 height times the quantity base 1 plus base 2. And finally, area of a circle, which is pi r squared. Now what we're going to be doing in this section is we're going to be using these equations to find the area of composite figures. Those would be figures formed by combining or potentially removing two or more basic figures. So we're just going to dive right in and go straight to examples because, again, this is an example of a lesson that we should already know how to do from junior high math. So here is an example of a composite figure. We're going to find the area of this shape. So if we look at this shape, the idea is that we need to be able to recognize other shapes within this shape. So what we have here is half of a circle and a trapezoid. Okay, the trapezoid has an area given by 1/2 times the height times the quantity base 1 plus base 2. Now the bases are relatively easy to spot. 12 is one of our bases and 16 is the other base. The difficult part is the height. Now that's based on the radius of the circle here. Since the radius of the circle is 5, the diameter of the circle is 10, which would make the height of this trapezoid 10 meters. So for the area of the trapezoid, we're going to do 1/2 times the height, which is 10, times base 1 plus base 2, which is 12 plus 16. That would be 1/2 times 10 times 28, or 140 square meters. Now, for the semicircle, semicircle means half of a circle, the area of that is 1/2 pi r squared. Now in this case, and on your homework, we're going to go ahead and estimate the value of pi. We're going to let pi be about 3.14. So the area of our semicircle, I always get in the habit of drawing a theta, that's not what that is. Area of our semicircle is 1/2 times 3.14 times 5 squared. So we're going to feed that to our calculator. 1/2 times 3.14 times 5 squared would be 39.25 square meters. So that's the area of our semicircle. The area of the figure is the area of the trapezoid plus the area of the semicircle. That would be 140 square meters plus 39.25 square meters, or a grand total of 179.25 square meters. That is how we approach these problems, and they should be relatively simple. We just need to find shapes that make up the larger shape and either add or subtract those pieces together to find the total area. Again, the area of that figure was 179.25 meters squared. Okay, so here's another example. Let's just do another one here. Here we have a shape that consists of two rectangles with a semicircle removed. So again, we've got a rectangle here and a larger rectangle here. We're going to add those two rectangles together. We'll call this rectangle 1 and this rectangle 2. So the area of rectangle 1 is base times height, that is 13 times 9. Feed that to the calculator. That is 117 square feet. Rectangle 2 is going to be a little bit trickier because we have to realize that the height of that rectangle is either 13 minus 7, which would be 6 feet, or the diameter of the semicircle, which would also be 6 feet. So this distance here is 6 feet. So the base times height for that is 8 times 6. My red is going out on me. Or 48 square feet. As for the semicircle, again, we will use pi to represent, or 3.14 to represent pi. The radius is 3, so we're doing 1/2 times 3.14 times 3 squared. That would be 14.13 square feet. So what we're going to do to find the area here is we're going to add the two rectangles together. And then we are going to subtract the area of the semicircle. So that would be 117 plus 48 minus 14.13. We feed those numbers to the calculator. And we get 150.87 square feet for the area of our composite figure. Again, that is 150.87 square feet. Let's do one more. This one's a little bit trickier. Not a lot trickier. Again, what it boils down to is, can you find the shapes? So once again, we have ourselves a semicircle here on the upper portion. That's a semicircle. And down here we have a trapezoid. Now we don't have as many numbers this time, but we do have markings. This one has 2 dashes on the bottom and 2 dashes up here, meaning if this is 14 meters, so is the top portion there. And if this is 6 meters for the radius of the semicircle, the markings say that is also the height of the trapezoid. So the only other thing we have to realize is that we also know the other part of the trapezoid here, this top portion, this length from here all the way across, which was essentially one of the bases of our trapezoid. This piece here is 6 meters. So if we want that length between these 2 points, we would add 6 and 14 together to get 20 meters. So what we need to do is find the area of the trapezoid and the area of the semicircle and add them together. So the area of the semicircle is again 1/2 times pi times the radius squared. For composite figures, it is normal place for us to use 3.14 to represent pi, and the radius is 6 meters. So that's 1/2 times 3.14 times 6 squared, or 56.52 square meters. For the trapezoid, 1/2 height times base 1 plus base 2. Base 1 is 20, base 2 is 14, and the height is 6. So that would be 1/2 times 6 times 20 plus 14, or 1/2 times 6 times 34. So the area of the trapezoid, feed that to your calculator, would be 102 square meters. The area of the figure is the area of the semicircle plus the area of the trapezoid. That would be 56.52 plus 102, or 158.52 square meters for the area of the composite figure. All right, ladies and gentlemen, there's a Google form also shown on Google Classroom that you need to do. That is a homework assignment, so as always, I'm giving you 2 nights to complete that assignment. You need to start it soon so that if you have questions, you can hop into line to get your help electronically. Again, everyone needs to be being responsible, doing their work daily, so that you do not fall behind. Thank you for your time.